tree diagram. What are we doing today? Fine. Tree diagrams. Let me just find my pen now. Okay, so a tree diagram is obviously a diagram. It's a way that we use to almost like summarize something that's happening in probability. Okay, so the first example that we're going to do is flipping a coin. Okay, now when you are asked to draw a tree diagram, you need to ask yourself how many possible outcomes are there, all right? How many things can happen? When we're flipping a coin, it will either land on heads or tails, right? Do we know that? Okay, so we have two possible outcomes. Therefore, we are going to draw two branches. And the tree diagram doesn't have to be a specific size. Okay, you're just going to take your ruler. If we're drawing two branches, we're going to just draw a straight line and a straight line. Okay, and that represents the two possible outcomes. Okay, now obviously we can't just leave it as two lines because, I mean, what is that? All right, it's just two lines. What are the possible outcomes when we're flipping a coin? Heads or tails, all right? So on the ends of these branches, you need to write those actual outcomes, all right? Normally for heads, it's fine if we just put an H, but let's write heads fully, just because it's the first example, sorry. And then for tails, that would be the other outcome. Okay, so you do have to have your two branches, and then you need to label those branches as well. Okay, we label them at the ends, please, guys, not like along the line. What we're going to put along the line, though, is the probability of each of those outcomes. Now, when you're flipping a coin, what is the probability of it landing on heads? What do you guys think? 50%. Okay. Now, it's fine for you to write 50% on your branch, but the fraction for that would be a half. Okay, so a half, 50%, 0.5, that would also be fine. So you have your branch. On the end of your branch, you label the outcome, and along the branch, you write the probability of that happening. Okay, even if they haven't asked for the probability of heads, you have to put it on your tree diagram. Okay, and then what is the probability of tails? If the probability of landing on heads is 1 out of 2, a half, it would be the same for tails, right? You have a 50% chance of the coin landing on tails. So let's put a half there as well. Okay, and that's your tree diagram. All right. Now, what if we are flipping a coin twice? So not only once, but twice. All right, let's do another one. I'm just going to make a star. Flipping a coin twice. Okay, Okay, now we're going to have two sets of branches, not only the one. All right. Our first set again is going to be heads or tails, because that is what can happen when we flip that coin. All right, so just leave a little bit of space because we're going to actually make another set of branches from the heads. All right, so let's do it almost like this. There we go. And then we go down as well. Now I'm just going to use an H and a T. Okay, it's fine for you to use an H and a T. You don't always have to write the whole word out for probability. Okay. The probability of it landing on heads is a half, and the probability of it landing on tails is also a half. Okay, this first set of branches represents the first flip. Now guys, the purpose of a tree diagram is to actually summarize all the different combinations that can happen. So if we're just thinking of flipping a coin, right? We can flip it once and it will land on heads, for example. Then when we flip it the second time, it might also land on heads again. All right, so then we have two heads. But is that the only thing that can happen? The first one can land on heads and then the second one on tails, right? Or the first one can land on tails and then the second one on tails as well. Or the first one on tails and the second one on heads. All right, so there are actually 4 different combinations of outcomes that we can get. So whenever you're doing a tree diagram, for your second or even your third set of branches, you need to draw it going from the first thing here, the first outcome, the heads, and from tails as well. Okay, so look at how this is going to look. We're going to do a set of branches going from heads. So your second coin can either land on heads or tails, but you have to do it from tails as well. All right, now this doesn't mean that I'm flipping a coin or the coin for a third time. It just means that I'm considering that my first coin might have landed on tails. All right, and then the second time it's landing on heads. Or the first time it's landing on tails and then the second time on tails as well. Or the first time it's landing on heads and then again on heads the second time. Or the first time it's landing on heads and then on tails the second time. All right, so whenever you're doing a tree diagram, if you have a second event, all right, so the second coin flip or coin toss, you need to draw those arms or branches going from both of the first ones. All right. Again, we need to put the probability. Guys, what is the probability of a coin landing on heads? Well, you don't even have to do it like that. It would be 2/4, but we almost just ignoring this bottom one. Hey, the probability of a coin landing on heads is still a half. All right, the fact that it's now drawn in a tree diagram doesn't change that. Okay, the probability of that second coin landing on tails is again a half because there are 2 sides to the coin. Right? And tails is one of those 2 sides. Here, this is the same coin, right? It's not a different coin. The probability of that same coin landing on heads, heads is one of the 2 sides. So it's 1/2, a half. The probability of it landing on tails, again, is a half. Okay, now guys, if you have more than one coin flip, let's just quickly label this here at the bottom. This part now represents the second flip. Okay, so it's almost like split up into sections. What you have to do now is we're going to have to list the final outcomes at the end. All right. For this first one, we didn't have to because this was the outcome, was heads, and this was the outcome, was tails. All right. If we have more than one thing, we need to actually list the final combinations of outcomes at the end. All right. So if we're following this first branch, we say, okay, at the first flip, it could land on heads, and then it could land on heads again. What does that mean? What am I getting? Heads and heads. Okay, so just write there, H H. That's one possible combination of outcomes. Or the first time it could land on heads and then the second time on tails. So that is heads first and then tails second. That's another possible combination of outcomes. Or the first time it could land on tails, second time on heads. So that is tails first, heads second. Or the first time it could land on tails and the second time on tails again. All right, so that is 2 tails that I'm getting there. All right. Now guys, they can ask you here, what is the probability of the coin landing on, let's make the first one 2 heads. Now what you're going to do for this now, do we agree that it's this one that I'm looking for, HH, 2 heads? Now in order to get to 2 heads, I need to have my coin landing on heads once and then a second time, all right? So this is almost asking for the probability of head and head, right? Does that make sense? You can write probability of HH, that's also fine, but I do want us to realize that this is an and question, all right? Oh, why does this thing keep freezing? Let me just quickly sort this out. All right, so for and, we're also always going to times, all right? That's important. So we're going to say a half times a half, which is equal to 1/4. Right, that is the probability of getting 2 heads, of the coin landing on heads and then on heads again. Now guys, this might seem silly because all of them are halves, all right? But it won't always work like that. Okay, this is a simple example, but you can have different fractions on each of those branches. All right. So if you want, we can just circle these ones. All right, that is what I'm doing for the first question. Getting the probability of 2 heads, and I am timesing them. When it's an and question. Okay, because it's heads and heads again. And you would do the same thing if they asked for 2 tails. All right, it would be the probability of tails and tails. So this half times that half. Yes. Again? No, you can just answer it. Yeah, sorry. Just for these ones, I just want us to have the and. Okay, but in the test or exam, you could just go to the calculation. All right, number 2 is a bit more complicated. So what is the probability of the coin landing on heads and tails in any order? Well, guys, if we're looking at the tree diagram, there are actually 2 final outcomes. where I have heads and tails. All right. Do we see that here we have heads and tails? I'm going to circle that one. I'm just going to use a different color now so that it's not pink again. But then what about the next one? Isn't that also heads and tails? Because the question is saying in any order, hey, it doesn't have to be heads first and then tails. It can also be tails and then heads. All right. So they're just saying heads and tails in any order. So now what we're going to have to do is we're going to have to find the probability of HT. How am I going to do that? Heads and tails. What do I do when it's and? I times them together. All right. So you're almost like following the branches to get to that outcome. So you're going to do a half times a half. That will be the probability of HT. But then we're going to have to add the probability of TH. And how am I going to get that? That is again an and question because it's tails and heads. So I'm going to do this half times that half. Okay, so let's write that out. Probability of, I'm just going to say heads and tails here. Or you could also have just said H and T, that's fine. So this is now going to be the probability of HT plus the probability of TH. All right, so if the question that they're asking you, if there are more than one of these outcomes that actually fall into that, then you're going to have to add them together. All right, now the probability of HT is going to be, I'm just going to write it in brackets because we're timesing and we're adding. How do I get to HT? I follow this H and that T. So I'm going to take this half and times it by that half. All right, to get HT. So I'm going to do a half times a half plus the probability of TH. I'm following the T and then the H. So I'm going to take that half from T and multiply it by the half from that H. All right, so again, it is a half times a half. Okay, from there you can type that into the calculator. You can do it in your head. All right, a half times a half is 1/4. That's also 1/4. So you're going to have 1/4 plus 1/4, which is 2/4, which does simplify to a half in the end. Okay, so the probability of getting heads and tails in any order is actually 50% or half. Right, I want us to do a different one now that doesn't just have the same numbers. We have different numbers. Okay, are we all done here? Any questions? All right, a bag contains 4 bar ones. And in brackets, I'm just putting a B. That means that on our tree diagram, we can just use B. All right, instead of writing bar one. All right, so 4 bar ones and 6 crunchies. Yo, do you still get crunchies? Is that still a thing? Is it? I haven't seen one in ages. Okay, and 6 crunchies, and we can just use a C for that. Chocolate is chosen at random and eaten. A second chocolate is then chosen. Okay, question 1. Draw a tree diagram of this scenario. Okay, how many chocolates are being chosen? Being taken out of this bag? 2, hey? They're saying that you're taking a chocolate out and then you eat it up and then you're choosing a second chocolate. So for our tree diagram, we're going to have 2 sets of branches. And how many types of chocolates are in this bag? 2 of them, hey? So our branches are only going to have 2 sections. Those 2 branches like that. Oh, now it's frozen again. What's going on? Put a B next to the one and a C next to the other one, please. All right, so like we said, bar ones, crunchies. There are 4 bar ones and there are 10 chocolates in total. There are 6 crunchies and there are 10 chocolates in total. Now guys, normally we wouldn't be allowed to leave it as 4 over 10. We would have to write 2 over 5, right? In a tree diagram though, it's the only place in maths where you don't have to simplify your fractions. Okay, just on the actual tree diagram. It's actually going to help us to not change it. You'll see now in the next step. All right, but if you are asked what is the probability and you have to give an answer, then you must simplify it. Okay, just on the actual tree diagram, you do not have to simplify. Okay, so this is the first chocolate that's chosen. All right, then they're choosing another chocolate. Now, guys, if you chose a bar 1 the first time, there were 4. How many bar 1s are left then? Because remember, you're eating a bar 1 now. All right, so are there still going to be 4 bar 1s in the bag? Okay, if you took one out, how many are left? 3. And are there still 10 chocolates if you took one out and you ate one? No, there are actually only 9 of them left, hey? So for your next set of branches, again, you have your B and your C for both of them because there are still bar 1s and there are still crunchies left. All right, so again, you have your B and your C. But now your probabilities are actually going to be different because you're taking a chocolate out, either a bar 1 and a crunchy or a crunchy, sorry, and you're actually eating it. All right, so the chocolates in the bag are not the same as when you chose the first one. So if we are looking at this branch, we are saying we ate the bar 1. All right. We are going to look at what happens if we ate a crunchy when we get to the second branch. All right. So if we took a bar 1 out, we are left with 3 bar 1s and 9 chocolates in total. If we're following this branch. All right, this branch is saying we took out a bar 1. But if we took out the bar 1, how many crunchies are left? Still 6, hey? We didn't eat a crunchy if we're following this branch. So we still have 6 crunchies left. But if we ate a bar 1, there are only 9 left in total. Okay, so both of those probabilities have to change. I hope that makes sense. If we're following this bottom branch, we're saying we actually ate a crunchy. So are there still 4 bar 1s? Yes. All right. But how many chocolates are left? 9. Because I took a crunchy out and I ate it. All right. I had 6 crunchies originally. Remember, if we're following this branch, we're saying that we took a crunchy out. Do I still have 6 crunchies if I ate one? No, I now have 5 and I have 9 chocolates in total. Okay, so this is a very particular type of question. All right, if you're taking something out and you're not putting it back in the bag, all right, then your probabilities have to change. What if the question said you're taking the chocolate out and then you're putting it back? Would these probabilities all have to change? right? If I'm taking it out and I'm putting it back, I'm still going to have 4 bar ones and I'm still going to have 10 chocolates as well. I'm still going to have 6 crunchies and still 10 chocolates. All right. The thing here is that we are eating the first chocolate. So that is why after taking out the first one, the numbers in the bag have all changed. Okay. I hope that makes sense. Let's do our outcomes here at the end. What's happening here? I'm eating a bar one and then I'm taking out another bar one. So that is BB, 2 bar ones. If I'm following these branches here, I'm taking out the bar one and then a crunchy. If I'm following the bottom branch there, I'm taking out a crunchy and then a bar one. Then a crunchy and another crunchy. So 2 crunchies. I never said the word crunchy in a short period of time like this. Okay, does that make sense, guys? That's the tree diagram done. All right, now number 2. What is the probability that? And then we have A, 2 bar ones are chosen. All right, 2 bar ones. Where is that on my tree diagram? Bar 1 and bar 1, Naomi? The first one, hey, that's BB. So the probability of getting BB, or you can write B and B. What am I going to do with those probabilities on those branches? I'm going to times them. All right, if you're following a branch like this, you always multiply those probabilities. Okay, so we're going to say the first probability here is 4 over 10. Then I'm going to times it by 3 over 9. All right, 4 over 10 times 3 over 9. Now let's see, you could do that in your head. Will be 12 over 90. So I want to check here, yeah. That is 12 over 90. Because it's 4 times 3 is 12 and 10 times 9 is 90. All right, but you can't leave it like that. You do have to now simplify the fraction. Okay, because we're not on the actual tree diagram now. So when you simplify that, it ends up giving you 2 over 15. Or you could have cross-cancelled at the beginning. All right, not actually cross-cancelled. You could have just simplified each of these ones because 4 over 10 is actually what? What's 4 over 10 if you simplify it? 2 over 5, hey? So this is actually 2 over 5 times, and what about 3 over 9? Is there a number that goes into 3 and 9? 3, hey, it will give you 1 over 3. And then if you multiply these two together, 2 times 1 is 2, and 5 times 3 is 15. Okay, so it doesn't matter how you get there, but you do have to get to 2 over 15 in the end. Okay, usually for these questions, you are allowed to use a calculator, so that should be fine. But you could also do it without one. Any questions on that one, guys? All right, the next one. So probability that 2 bar ones are chosen. Now the probability that 2 crunchies are chosen. Okay, so 2 crunchies, so that is CC, hey? The last one here. So that is, basically they're asking us for the probability of CC. So now we need to take the probabilities leading up to CC on those branches and times them together. So let's see, what do we have there? CC is over here. So we're going crunchy and then another crunchy. So we're going to do 6 over 10 times 5 over 9. Okay, 6 over 10 times 5 over 9. Okay, let's see if we can simplify that before we multiply them. We can actually cross cancel quite nicely in this one. Hey, do we see with 6 and 9? 3 will go into both of them. Right? How many times does 3 go into 6? Twice, and into 9? 3 times. What about 5 and 10? 5 goes into both of them. Right? 5 goes into itself once and into 10 twice. Now what happens here? We have a 2 and a 2. Can't they cancel each other out? What's 2 divided by 2? Just 1, hey? So these 2's will actually also cancel each other out. So what am I left with? 1 times 1 over 3. What is that? What's 1 times 1 over 3? 1 over 3. All right, that's the final answer. If you multiply them straight away, it wouldn't have been too difficult. 6 times 5 is 30. And 10 times 9 is 90. All right, and then you can just see that 30 goes into both of those. So that will also get you to 1 over 3. Okay, so that's actually quite a big chance to get 2 crunchies, a third. Right, the probability of getting 2 crunchies, there's a third. Okay, now the third question. What is the probability that at least one bar 1 is chosen? Okay, now guys, if we're saying at least 1 bar 1, does that mean that I can also choose 2? Will that also fall into that category? If I have 2 bar 1s, do I have at least 1? Okay, yes, all right. But if I only have 1 bar 1 and the other one is a crunchy, I have at least 1 bar 1, right? So for at least 1 bar 1, we're going to look for all of the ones that have a B in them. All right, so let's write that there. All of the final outcomes with 1 or more bar 1s. Because they're saying at least 1. That means that we have to have 1 B, but we can have more than 1, all right? So if we go back up to our tree diagram, let's circle all of the ones that have at least 1 B. Do we agree that the first one has 2 B, so that is at least 1, all right? So that one. What about BC? Does that have at least 1 bar 1? If we have 1 bar 1 and a crunchy? Yes. What about CB? We have a crunchy and a bar 1. Is that at least 1 bar 1? Yes. What about 2 crunchies? Is there a bar 1 there? No. So we're going to have to find this probability, which we actually already have. Okay, we found it in A. But if we didn't have it, how would we find this probability? By saying 4 over 10 times 3 over 9. Then we're going to find this probability by saying, following the branches and multiplying those. So 4 over 10 times 6 over 9. Then we're going to find this probability by saying 6 over 10 and 4 over 9. And because I have more than 1, what must I do with those 3 probabilities to get the total probability? I'm going to have to add them together. All right, it's like what we did here. Where we had heads, tails, and tails, heads. All right, we found the probability of each of them and we added them together. All right, so let's write that down. It is the, I'm going to write here, probability at least 1B is equal to, now I'm going to list the three that we're going to have to add together. Okay, it's the probability of BB plus probability of BC plus probability of CB. So guys, if it's more than one final outcome on your tree diagram, you're going to have to add them together always. Okay, if it's just one, like we had here with BB or CC, for BB, there's only one BB. All right, so we just times those numbers. For CC, there's only one CC, so we just times those numbers. But if it's three of them, we have to do each one separately and add all of them together. Okay, and that's what you're always going to have to do. So for the probability of BB, are we all clear on the fact that we found that in A already? Okay, so we don't have to do that multiplication again. We already found that answer. That is 2/15. Okay, if you didn't have that already in A, you would have had to multiply it. Plus probability of BC. We haven't calculated that one yet. So BC, let's go back up to the tree diagram. We need to find the branches leading up to BC and multiply the probabilities on those branches together. All right, so what is that? 4/10 times 6/9. So 4/10 times 6/9. All right, that's how we'll find the probability of BC. Plus the probability of CB. We need to go back up to the tree diagram. We need to find the branches leading up to CB and multiply the probabilities on those branches. So that's 6/10 times 4/9. Okay, again, you can do this all in your head if you simplify those fractions, but let's just do that here. Okay, so this one is 2/15 plus, if you calculate that one, that will give you 4/15. Right? And then the next one is actually going to give you the same value. Let me just double check. We have a 6 and a 10 and a 4 and a 9, yes. So that one is also 4/15. All right, now do we see that we have the same denominators for all of them? Let's revise adding fractions together quickly. If the denominators are the same, we can just add the numerators, right? So what is 2 plus 4? 6 plus another 4 is 10. So we have 10/15. Is that the simplest form of that fraction? 10/15. What number goes into both of them? 5. 10 divided by 5 is 2. And 15 divided by 5 is 3. So 2/3. That's the final answer. But guys, if the question paper doesn't say anything about not being allowed to use a calculator, you can actually just type that. Hello, thank you so much. Cool, thank you. You can just actually type that line into the calculator and write the answer down. Okay, if they say that you're not allowed to use a calculator, you would have to actually write all of these steps down. Okay, so it just depends on what they say in the question. All right, are you ready to practice some on your own? Exercise 3, which is in the notes on Google Classroom. I will put it on the board for you. So what I want you to do is just 2 questions. So exercise 3, in the first question, they've actually given you the tree diagram. And in the second one, you have to draw it. Okay, so exercise 3, this is in the notes. I will put it on the board so that you can take a picture of it. Okay, this is due for Wednesday, please, guys. On Wednesday, we're marking this. We're doing two-way tables and we're doing some questions from another worksheet. And then we're done with probability. Okay, so if you can study on Friday. Okay, put it on the board. Okay, do you quickly want to take a picture of question 1, and then I'll just move it up so that you can take a picture of question 2 as well. Then you don't have to look for it in the notes. Lots more work on this at home. Yeah, I just want to talk about this one quickly. They just like consider the tree diagram below and answer the questions that follow. All right, so this is obviously a morning vibe, okay, where your alarm is on or off. So they're saying that there is a 0.7 chance that your alarm will be on and a 0.3 chance that it will be off. All right, so 70%, 30%. Does that make sense? Then if your alarm is on, you have a 0.9 chance, so a 90% chance of being early. But if your alarm is on, you still have a 10% chance of coming late. All right, you know, I mean, that's true. If your alarm is off, do we see that it's very different? Only a 0.2 chance, so this is a 20% chance of being early and an 80% chance of being late. All right, if you with your alarm. So that's what they're giving you. You need to work with those values. Okay. So now they're asking what is the probability that my alarm will be on and that I will be early to school. When we're doing and, what do we do in our calculation? We times. Okay, so alarm on and early. So for that question, we're going to do 0.7 times 0.9. Okay, type it into the calculator, that's the answer. You can leave it in fraction form or as a decimal answer, it's fine either way. Next one is also an and question. Again, you're going to take two fractions or the two decimals and multiply them. Now for B, they say, what is the probability that my alarm will be off and that I will be early to school? Right? So for the first question, we're calculating this one, alarm on and early. Second question, we're calculating alarm off and early. In C, they're saying, therefore, what is the probability that I will be early to school? Right, now guys, there are two ways in which you can come early to school. Either your alarm is on and you come early, or your alarm is off and you come early. So in C, they're actually asking you for this one and for that one. And what do we do when it's two outcomes on the tree diagram? We need to add them together, right? So in A, you're going to calculate this probability. In B, you're going to calculate this probability. In C, you're going to have to add those two together. Right. Then in D, what is the probability that I will arrive at school? What do you guys think? Did they say anything here about not arriving at all? No. So what do you think? What's the probability of arriving at school? 0. 0? I would say 100%, okay? Because you're arriving early or you're arriving late, you're still arriving. Right? Does that make sense? So early or late doesn't matter in that case, actually. So for D, the answer can be 100% or the same as 1. Okay, 100% is the same as 1. All right, so that's the option. Okay, I'm going to show you number 2. So you can take a picture of that and then put 1 back up. Okay, there is question 2. Just take a picture of that quickly. This at the bottom is just another extra little explanation. You can read through it if you want. Okay, there is number 1 for you guys. You can work on that. If you don't finish this in class, you're going to have to finish it either this afternoon or tomorrow. Okay, we have to mark this on Wednesday.